Surviving these modern pressures requires a significant supply chain fracture. Global nitrogen and fertilizer prices have spiked, driven by logistical bottlenecks and severe production shortages. These economic pressures are compounded by environmental reality. Nearly 60% of the United States is currently under severe drought conditions, placing extreme stress on agricultural water availability. For turf managers, these twin pressures land directly on the fairway. Maintaining high-quality turf now requires a constant battle against rising input costs and dwindling water supplies. The industry is responding with a data-driven framework called the 2026 Low-Dose, Low-Nitrogen, or LDLN, strategy. It is an approach designed to maintain playability while aggressively scaling down inputs. Surviving these modern pressures requires decoupling the biological health of the turf from the sheer volume of resources applied to the soil. To establish the baseline for this strategy, an independent 2023 trial was conducted in Ireland on a fescue and poa annua sward growing in a natural lynx root zone. The standard industry baseline for granular urea was set at 0.19 pounds of nitrogen per 1,000 square feet. The Aquaritin 19 protocol used a microscopic dose, just 0.0007 pounds of nitrogen. Despite applying 4,700 times less nitrogen, the experimental plots maintained identical visual quality and identical NDVI health scores as the heavy urea plots. This creates a biological puzzle. We need to understand how a turf manager can reduce the nitrogen supply by 99.9% without starving the plant. Solving this paradox relies on measuring the mechanical efficiency of the delivery system rather than the total volume of the application. Traditional granular urea delivery is inherently inefficient because it relies on the soil as a middleman. In sandy root zones with low cation exchange capacity, dissolved nitrogen moves quickly. Gravity and water work together, rapidly pulling the nutrients downward before the shallow turf roots can capture them, meaning a high percentage is lost to environmental leaching before the plant can access it. Nanotechnology is designed to bypass this root zone bottleneck entirely. Aquaritin 19 uses nano-encapsulated nutrients to move the point of entry. The particles are absorbed directly through the stomata and cuticles of the leaf blade. Foliar absorption is direct. The nutrients enter the plant tissue immediately, skipping the slow and volatile process of soil uptake. By utilizing the leaf as the primary entry point, the LDLN system eliminates the variable of soil leaching from the agronomic calculation. This direct path allows for a 4,700-fold reduction in applied volume. When waste is eliminated, the required input volume drops to nearly zero. To prove this efficiency, we have to look past the surface and verify that the plant is actually metabolizing these nanonutrients. The 2023 leaf tissue analysis reveals internal accumulation. Heavy urea applications yielded a 21.45% nitrogen increase. The Aquaritin dose showed a 38.84% increase. Phosphorus and potassium data follow the same trend, with significantly higher accumulation in the Aquaritin samples. This highlights the disconnect between application and absorption. A massive granular input resulted in lower internal levels than a tiny, precise foliar dose. These results confirm that nano-delivery provides higher net accumulation. The plant reaches a peak nutritional state by bypassing the environmental losses inherent in soil-based programs.
The trial proves that high-volume fertilizer application does not correlate with high-volume internal nutrition. These internal metrics lead to a change in the physical growth habits of the turf. Plotting shoot growth dry weights, urea shows volatile spikes of surge growth. This operational burden forces superintendents to increase mowing frequency to maintain playability. In contrast, the Aquaritin curve is remarkably stable, promoting a balanced root-to-shoot ratio and consistent color without volatile leaf expansion. Eliminating those growth flushes directly impacts the maintenance budget, reducing fuel use, reducing labor hours, and mechanical wear on mowers. This leaner, LDLN-managed turf is physically more resilient. It lacks the soft, lush tissue of over-fertilized plants, making it more resistant to the heavy traffic of a busy golf course. High nitrogen loads produce lush, watery leaf growth. This LDLN approach creates a hardier leaf structure that lacks the soft, excess moisture where fungal pathogens typically establish. In this way, precision nitrogen delivery serves as the primary lever for controlling both plant health and the weekly operational budget. This stability creates a domino effect on the rest of your chemical program, particularly regarding plant growth regulators, or PGRs. Standard nitrogen programs often require heavy PGR applications specifically to suppress the surge growth caused by the fertilizer itself. The 2023 trial compared total chemical inputs needed for identical growth regulation. Because Aquaritin 19 eliminates surge growth at the source, the required PGR rate dropped by 25%. The trial also found that surfactant requirements simultaneously dropped by 25%. When you maintain stable volumetric water content without aggressive top growth, the plant requires significantly less intervention from wetting agents and surfactants. This also promotes water conservation. Superintendents no longer need to rely on heavy saturation cycles to move granular nutrients through the soil profile. By lowering the nitrogen input, you naturally lower the entire chemical threshold required to regulate and maintain the plant. When we combine the findings into a single dashboard, we can see the cumulative impact of the low-dose, low-nitrogen strategy. The nitrogen volume plummeting by 99.9% is the primary saving. This is followed by a 25% reduction in the secondary chemical budget for regulators and surfactants. As mowing frequency and fuel use drop as well, the total operational cost for the facility enters a sharp downward trajectory. Adopting the LDLN system represents a mathematical restructuring of a golf course's operational profit and loss statement. Beyond the immediate financial benefits, turf managers are preparing for strict 2026 environmental regulations and local nitrogen caps. There is increasing municipal and federal focus on preventing nitrogen runoff and protecting groundwater from leaching. Traditional granular applications face increasing legal and regulatory hurdles. A zero-leaching foliar model provides a path to high-performance turf that meets the strictest environmental standards. Shifting to a nano-enabled foliar program functions as both a fiscal optimization and a proactive step toward legal compliance. The 2023 trial proves that achieving the gold standard of playability actually requires less input, provided that input is delivered with precision. True agronomic efficiency is found in the delivery mechanism. In modern turf management, blind volume is the enemy of performance.